So I had you set up two graphing grids. We're going to be graphing this on the first of them. And so go through the process. This is one of those 1/3 to the power of x ones. And so it gives you a chance to really see, based on the work we did yesterday, do you remember it and can still employ it with all the little details. And basically our goal today is going to be going through all the stuff we've been doing the last 2 or 3 days of class. Because we've covered a lot of different little things. We've looked at all the different variations of graphing exponentials. We've also been looking at the calculations done with logarithms. And so we really just want to bring those things back, reinforce them, and maybe take care of any of the little details that could bring up questions as we go forward. So it's really about wrapping things up and putting a bow on it so that you can feel really confident moving forward. Now, as you take a look at this one, there might be questions that come up, and of course, if there's any point where you got stuck as you're doing it, then you know, okay, this is the part I really need to focus on. That's also why I always have you do it on your own first. Math makes a lousy spectator sport. You don't want to just sit there and watch me do it and think that you learned something. You don't really learn it until you can do it. And you don't remember it until you try doing it. And so you always try it first, then check it, and go from there. All right. Now, the first thing you're going to do here is you need to at least be thinking about these things. Whether you write them down or not each time you do one of these, that's up to you. But at least be thinking about what each of these. Your parent function here is just the 1/3 to the power of x, because the -2 part of it, that is a transformation. That's shifting it down 2. Now, since it's shifting down 2, then that means our asymptote is down 2. So, since we know that our asymptote is down at -2, you notice that's the first thing I put on my graph. So, I draw in the dotted line. Yes, draw in the dotted line for the asymptote. If you leave that out, making your graph gets a lot harder, and it's highly likely that you're going to have some point that ends up in the wrong spot, because it's not clear what you're graphing relative to. And when I say relative to it, that's literally what I'm talking about, because some of you, the x-axis still hanging out there throws you off, but really what you're doing is mentally, you're now ignoring the x-axis. All we care about is where that asymptote is, and everything is relative to that. And so when I say we put our first point up 1, because of course anything to the power of 0 is 1, it's 1 above the asymptote. Has nothing to do with the x-axis, just the asymptote. And so we do put our first point up at 1 from the asymptote. But now, what do we do when actually graphing this? As we go to the right from there, I'm going to be multiplying my heights by the base, and it's always by the base. So I'm going to be multiplying everything by 1/3. If you prefer to think of it as dividing by 3, of course that is the exact same thing. And so my 1 that I'm up here, that's going to become 1/3. So I'm going to go ahead and plot a point as close as I can to 1/3. Now from there, we have to actually go through and plot 1/3 of that height. Now, of course, if you're doing this on computer or something like that, you could just do that and then say, okay, now 1/3 of this distance, okay, well that would be around about here. Can you do that on your paper? Obviously not. You just are going to gauge it as best as you can. Get as close as you can to that 1/3. And then after that, we go 1/3 as high as that. And you notice very quickly we're basically sitting on the asymptote. Obviously we aren't actually hitting 0, but it's so close to 0 that just by hand we can't differentiate for it. And so plot at least 2 or 3 points on that side. And of course you know from there it's just going to be going right along the asymptote. So you know what it's going to be doing as it goes along here. Alright, now to the left side. When I went to the right, remember, I multiplied by 1/3. So as I go to the left, what am I going to be doing? I'm going to be undoing that. Well, undoing it would be like dividing by 1/3. But a lot of us don't like the idea of dividing by 1/3. That's a weird idea for us. So we have to remember what dividing by 1/3 really means. Remember, to divide by a fraction, that's the same as multiplying by its reciprocal. The reciprocal of 1/3 is 3 over 1, or just 3. So as we go to the left, I am multiplying my heights by 3. So that height was at 1, of course. I always start at 1. And so then I multiply that by 3. And so it goes from 1 to 3. And then I'm going to take that height and multiply it by 3. So that's going to be up 9. And so then we get our points on the left side there. Now once we have those points drawn in, we can go ahead and draw our curve through. When you draw the curve, notice I am extending it out to the edge of the graphing grid. I don't stop it at the top point because, of course, I know it continues. And so extend it up following that same kind of curve to the edge of the grid. All right, now that we made our grid, our graph, I want to take a look at these last two questions over here, the domain and the range. What is the domain of my exponential here? Yep, all real numbers. It's always all real numbers for an exponential. And the range, it's not all real numbers, so it's going to have a y in it. What is the number that is in our range? It is -2. How do I know it's -2? Because that's where the asymptote is. It's always the asymptote. Now in this case our graph is above it, so that means greater than, and I mean greater than, not greater than or equal to. Because of course that's the whole point of what asymptote means. It gets close to it, but it never actually will reach -2. Yes, that range should be y is greater than -2. Sorry about that. On your second graphing grid, I'd like you to now graph this function, y equals 4 to the power of x minus 7. So we can remember how to do it with whole numbers and how to deal with that -7 that's in the exponent. Now, of course, one of the first things that you're thinking about, I hope, is what's the parent function and how's it being transformed? Whether you write it out explicitly like that or not, you need to know the answers to those questions if you're going to make the graph. So, the parent function, that's just going to be our 4 to the power of x part. Notice what's not part of the parent function though, that -7. Now since the -7 is in with x, that means it's moving it in the x direction. Which way does minus move it? Right. Yep, to the right. Now since the only transformation here is that it's shifting right 7, our asymptote, which started here at 0, if I take that horizontal line and move it over, it's still at the same height. And so our asymptote is unaffected by that horizontal shift. Now, the one thing that sometimes is a little bit tricky for people is knowing where do you put that first point. And it's all about knowing where does it normally go. So, to place that first point, normally it'd be starting up 1 from the asymptote, right on the y-axis there. Now, in this case, it's not going to, though. In order to know where it goes, I know that this thing is shifting right 7. And so I'm going to take that point and I'm going to shift it to the right 7, which is going to put it starting over here. So notice it's still starting up 1, just it's starting over at 7 instead. And then once you have that point, then all you need to know is the parent function. All right, now that I have that first point plotted, all I have to do is know what I'm multiplying that height by. And since our parent function is 4 to the x, that means I'm taking that height of 1 and I'm going to multiply it by 4. So 1 times 4 is 4, so that one's going to go up 4. Then, to know my next height, I'd multiply that last height by 4. So 4 times 4 is 16. Well, that 16 there, well, that's going to take us off our graphing grid. So, at least for this particular grid, I can only fit on that one other point to the right. But of course, when I draw my graph in, I will still extend it out to the edge of the graphing grid. When you do that, notice where I put the end of the line up here, end of the curve. I did not go over like this. I did not cross that next line because we know that at this line, it's got to be up at 16. So it wouldn't make sense for me to go past that. I'm always kind of envisioning where it would be going as I go up. All right, now let's go to the left. So as I go to the right, I multiply by 4. As I go to the left then, what am I going to do to the heights? I'm going to divide by 4, or multiply by 1/4, same idea. they're going to be 1/4 as high. So the 1 here is going to become just a 1/4 here. It's not very high at all. And then, of course, we go 1/4 of that for the next one, which is at a 16th. Are you going to plot it at exactly 1/16? Probably not, because we're doing this by hand. But you can at least get pretty close to it. You'll know that that's a very, very small number, something very close to our asymptote. And so I plotted at least 2 points on that side, always at least 2, please. And then we can go ahead and draw our curve in. And then once we have our curve, we can go ahead and think about domain and range. The domain, it's exponential, so it's all real numbers. And the range, it's not all real numbers. It'll be y is greater than, because it's above the asymptote, 0, because the asymptote's at 0. Now, if we can make the graphs, we can actually do much more now, too. If I give you the graph, you should be able to write the equation of that graph. All right, so to write this equation, one thing that we can glean really quickly and easily from this is we can see where the asymptote is. The asymptote's up at 2. So I know that my equation is going to have a +2 on the end. But the rest of the details, it's sometimes at least a little bit harder to tell if you just focus on the curve. You're not so interested in the curve, because that tells you that it's an exponential, but that's about it. What you're really interested in is the whole number point. Those are what's going to let us really figure out what are these exact numbers. And so if I focus on those, I can start setting up my equation. It's going to be y equals, and we know we got that +2 on the end because the asymptote's there. And we know it's something to the power of x because we can see by the shape. But in order to figure out what our base is here, what we're going to do is we're going to look and actually see how are those heights changing. And so you notice I start up 1. Well, that's where I, of course, expect to start, right? I go from 1 to 2. And then I go to 4. And then I go to 8. What am I multiplying them all by? 2. And so that tells me then that it's got to be a 2 to the power of x. Once you plug that in, you have your equation. So our equation here is y equals 2 to the power of x plus 2. All right, so let's start building this equation. Of course, we can start with y equals, right? And we can tell by the shape of the graph that it's going to be something to the power of x. So I'm going to go ahead and put that power of x in. All right, so my asymptote. Where's my asymptote? It's up at 6. And that's what I care about. I care about where the asymptote is, not where the first point is when it comes to the vertical shift. Some people get focused on that first point like the y-intercept or something. No, it's about the asymptote. All right, and what am I multiplying my heights by each time? Well, of course, I start at 1. And then it goes to 4. And then it goes to 16. What am I multiplying by?
4.
I'm multiplying each one by 4. But as some of you have already observed, of course, this isn't the final equation, right? Because if this were my final equation, it would actually be up here. It's below the asymptote. And anytime it's below the asymptote, you got a negative out front of it. Now, one little side detail. Every now and then, somebody tries to be really diligent at this point and says, I'm going to put parentheses in to make it clear that that's what I mean. But this isn't correct. When we write -4 to the power of x, remember this actually means 4 to the power of x made negative. So if you were going to put in parentheses, this is where you'd put them in. But you don't need them. I just want to make sure that you remember, of course, what that negative is really meaning and what it's really doing. All right, now when doing this problem, one thing that at first gives us a little bit of trouble is telling how far is it really moved up or down. As you look at it, how far is this graph moved down? Did you look for the asymptote, or did you look for that first point? I didn't draw the asymptote in on that first graph. You had to mentally put it in yourself in order to be able to see where that would be. And so once we've done that, then we can go ahead and now see how our equation is going to be. And so we know that it's something to the power of x minus 3. What is to the power of x in this case? Well, notice I start down 1, and then I go down 2, and then I go down 4. What am I multiplying them all by? 2. And so it's got to be a 2 to the power of x. And since we're going below the asymptote instead of above the asymptote, it is going to be a negative. So we're looking at y equals negative 2 to the power of x minus 3. All right, and so when we do this one, you should get y equals 3 to the power of x minus 7. And again, I didn't draw the asymptote in for you, so you actually had to visualize where it was. And sometimes that can make it a little bit trickier. Now, how do I know where it is? I can see where the graph is tailing off here, where it's leveling out. That's got to be at the asymptote. And so you notice that if I extend that over, that I can kind of see where it is down at negative 7. And then it makes it easier to see what those counts are, because of course we start up 1, then you can see that we're actually going up 3 from there, so I multiply by 3, that's why it's 3 to the power of x. It's above the asymptote, hence positive. No negative needed in this one. The other thing we've been doing recently is logarithms, right? So let's continue practicing our logarithms. And I want to start practicing the logarithms with stuff like this. Just switching between exponential and logarithmic forms. I'm starting here because I'm hoping that by now you've gotten this process memorized. You should be able to switch from exponential into logarithmic form and logarithmic back into exponential form without your notes. If you're not quite there yet, of course, use your notes to get there. But know that this is the time when you really should have done enough of these to actually know that pattern. Now, for number 2, if all you did was just follow the same pattern, you'd end up with something that looks like this. Log base 10 of z equals a. But I don't actually want that to be your answer. Because yesterday we saw log base 10 can be written shorter. This is the logarithmic equivalent of saying 1x. We don't need to write that 10 in.
What do we do?
Log base 10 is just log. And I always want you to have your answer simplified all the way. So if you wrote log base 10, you know the pattern, but now we go one step further. If you ever find yourself writing log base 10, erase the 10, and then just keep going, because we do not need to write that 10 in.
If you did write the 10 in.
Now, when we go to the right side, we're using the same pattern. And actually, one other thing to mention, because it is a question that comes up here and there, does the order about which is on which side the equal sign matter? Like on that first one, could I have written it as 2 equals log base 9 of 81? The order of that part doesn't matter. It's not significant about which one's on the left and which one's on the right. It just matters which numbers are in the logarithms and which number is all on its lonesome over there. All right, number 4. That becomes 5 cubed equals 125. And then we hit number 5. And number 5, again, you had to remember, if the base isn't written, what is it? And so mentally, in your brain, you're probably inserting right into, after that g, you're actually inserting that 10 into your logarithm statement there. And then you can go ahead and change it into exponential. Go ahead and check those last answers on this side. Now, yesterday, of course, we did one more thing with our logarithms. We saw that all this reordering can actually be put to some use. We can actually do some calculations on these. And so, the last thing that we're going to be going through today is these 4 problems. What I'd like you to do is go ahead and calculate each of these values. You're going to need to use that change of base formula that we added into our notes yesterday. Use your calculator. In this case, ran to the thousandth place. Did say that we need to use change of base formula when doing these, so let's just check that first one, make sure you're heading in the right direction. So the change of base formula says that we're going to calculate this by doing a log divided by a log. Then it's just a matter of knowing which number goes where. One way to remember it is that the base always goes on the bottom. Or the number that I had to write lower in my logarithm, I write it lower in the fraction as well. Either way you do it here, for the number 1, you'd see that 8 goes on the bottom. So you're going to type that into your calculator. If you're doing it on a graphing calculator, remember log 1/6 and the parentheses, then divide by log 8. Okay? If you're doing this on a scientific calculator, however, you got to be a little bit more diligent. You go 16, press the log button. Press divide. 8, press the log button. And then press equals to tell it to do the division. So you do get an answer of 1.33 for that first one. To get it here, this is how you type it into the scientific calculator. I wrote there in the red. So you can actually see the button keystrokes that you would go through and what order you put them in to get it to come out right on a scientific calculator. Because for some people I know it's a little bit tricky. That'll help you get there. Check the rest of the answers you got. Make sure they're all looking good. If for any of them you didn't quite get the right answer, check and see why. Make sure you were able to get the right answer from it so that if it comes up again, you'll be able to get the right answer consistently. One little detail to note, you'll notice in number 3, there's no calculation shown. I didn't show any work. Why? Because I didn't have to do change of base in number 3. Log 50, I can just type 50 in the calculator, press the log button, and I got my answer. Nothing fancy in that case.